Okay, so welcome everyone to today's compiler architecture meeting. We have 3 topics to discuss today. The first is I think just coming to some kind of a resolution on the use of an issue template to describe any proposals for new IL opcodes. We've got a new proposal for an API on comparator nodes to ask for the underlying type that's being compared. And then we'll have a discussion on hopefully coming to some kind of a consensus on some clear language and guidance around the use of the TR namespace and the OMR Compiler namespace. Okay, so to kick things off, I'll talk about the issue template. So when I had this on the agenda, there were still some open questions to be answered about that, but Charlie Gracie actually added some comments to the pull request. So essentially, what that pull request proposed was the use of an issue template for when, a special issue template for when someone wants to propose a new IL opcode, and within that template, it basically provided a series of questions that the submitter would have to answer and provide justification and that sort of thing. I don't think that there was any question about the contents of that form, but the questions were really around the form in which it would be presented. So the way that I thought about doing it was with an issue template, but you know, obviously if another way of doing it was basically just whenever somebody wants to propose a new IL opcode, we just point them to the document to basically fill out all that information and then submit it as via regular issue. The challenge that, or one of the drawbacks of an issue template were that when you create one in GitHub, it actually presents your issue template, if there is only one, fairly prominently, and then it really relegates the other ones to be into a fairly small link. We can get around that by actually creating a generic issue template for any other issue, and the discussion that ensued in that pull request basically said that we can provide much more information than we can with a generic template by by supplementing it with any additional information that we want. So I think that's the way that we're going to go. So what I'm going to do is to actually create a template for a generic issue template as well, and include that as part of this PR. I'll get it ordered in such a way that the generic template will appear before the IL opcode template, and I'll get that pushed back up there for everyone to review and comment on if needed. But if anybody wants to bring up anything now to discuss, please do. Otherwise, I'll just sort of proceed on that, and then we can continue making comments in the PR as necessary. So I'll just pause in case anybody wants to bring anything up. No? Okay. Sounds good. Okay, so let's move on to the next one. It's a proposal from Andrew Craik in issue number 3302 to talk about creating a new kind of an API for a comparator node. So I'll turn the discussion over to him.
Yeah, so I think the issue summarizes what I was finding, but the gist of it is the following. When the OMR node API was cleaned up as part of the refactoring to open source OMR and subsequent cleanups that happened, there were a number of capability queries added to the nodes which allowed you to test things like if it's a comparison for equality or a comparison for order. And there was a sweep done through the compiler that replaced a number of places where there were long lists of sort of equality opcodes or comparison opcodes with these capability queries. Now, unfortunately, at the moment, the capability queries don't tell you anything about the kind of thing being compared. And I found that in some cases the refactoring actually has introduced a bug wherein if you feed a node of, say, non-integer type into that pathway, where the previous specific opcode comparisons would have prohibited a particular pathway from applying to that non-integer type node, it's being replaced with like a compare for equality test. And if you pass a non-integer type into it, it will now evaluate as if, or whatever, as if it was an integer comparison, and you can get incorrect results. So there's an example of that in the ternary evaluator in the x86 code generator, where if you generate a ternary that is evaluating a floating point condition, so you've got like a ternary with like a F compare GUE or something there, like that, under it. The F compare GUE will feed itself into the equality pathway by answering yes to is comparison for equality, but that pathway was originally just testing integer typed comparison opcodes. And so now the floating point comparison gets evaluated as an integer comparison, and, well, everything goes wrong after that. So you can fix that kind of problem at the moment by going in and necessarily then having to look at the child of the compare to know the kind of compare that you're dealing with, right? So all of the comparisons respond with integer as their type because they will produce true or false. But you don't have a way in the opcode properties at the moment to ask, what is the data type that you compare? Are you an integer compare? Are you a floating point compare, etc.? And that turns out to be a pattern that is quite useful in a lot of parts of the compiler, where especially we're interested in integer typed comparisons because there's lots of things you can do with those, and floating point comparisons are necessarily much more sort of difficult to play with given the wonderful vagaries of floating point that we've discussed previously in this meeting. And so at the moment, to do a fix, I have to do a fairly ugly code pattern where you kind of do is compare for equality and go grab the first child and ask its type, because that should match the type that the opcode expects. And you then make a rather large assumption. You make the assumption that the second child is probably going to have the same type, you hope, and then proceed with whatever it was that you were planning on doing. The kind of thing that we're comparing is sort of intrinsic to the comparison opcode. So kind of what I would like to propose is that we add a query that will let us ask the comparison opcode, so the if compare family, as well as the various compare on their own versions, what the data type is that they compare. I haven't come up with a good name for that yet, but like get compare data type or comparison data type or something like that was kind of what I had in my head. To then be able to say, are you an integer type compare or something like that, so that you could deal with these cases.
So you want the more general case where you ask it for the actual data type that you're comparing, as opposed to the question, are you comparing integral types, or are you comparing a float?
I'd be open to having both. I think they both could be useful in different places in the compiler. Sometimes sometimes you do want to discriminate between a double floating point and a single floating point, for example. But in other places, yeah, all you want to know is that it's an integer type, and that's good enough.
I guess that would be more of a convenience, right? Because you could get the data type back, and then you have to ask a second question on top of that data type.
Yes.
Ask its property, whether or not it's
whether it's an integer or not. So I mean, we could fold that detail in to save verbosity in the code. But I think that if we expose something that says, are you an integer type to compare, being able to ask specifically what type of the compare you have without having to reach into the child would seem to make sense to me, just from the symmetry of the API.
So the if compare equal to opcode doesn't have a data type today. Does adding a data type solve this?
So
Only for if compare, not for the compare opcodes.
well, and it also so the comment was the if compares don't have a data type. Could we add a data type in there? Well, yes, you could. It would be a bit of a corruption of the meaning of data type, because data type means the type that the node produces, and an if compare does not produce a value. It's a treetop that does control flow. The notion of what are you comparing holds true for both the ifs and the non-if compare equivalents. And the non-if compare equivalents have data type integer because they produce 0 or 1, and as an integer value, the 4-byte integer value.
So the expected data type of children is specified currently in the properties table and is used by the IL validator to make sure that the types of children matches what it's supposed to be. So I think that information is there, and I'm trying to figure out whether the query is to get that information from the properties table. But I think that's already halfway there to solving what you need.
It would be halfway. I mean, it would be exposing the data type. It's the question. The second half of the question is, do we want the aggregation queries of like, is integer comparison or is floating point comparison?
Mm-hmm.
Sorry?
I was just trying to find where the validator asks that question. I see the data in the properties table there.
Yeah, I wasn't quite sure how to get it out when I was trying to do this either.
Yeah. I remember solving this problem before, and
You furious gripping.
So,
Yeah.
so I guess that's like one of the top level questions would be, do we know that your use case came from wanting to look at compares?
Yes.
The question is, does the query have to be only about compares, or would there be other, like there are other nodes that where you might want to ask a question about the children types?
So I do see a query on IL ops that gives you the expected child type. That's in OMR IL ops, and it's called just expected child type.
that sounds familiar.
So there is a query.
Child number for that?
Yeah. The comparison opcodes, as far as I can tell, all have just 2 children, and they're both of the same type.
Yep.
So you could just ask for the type of the first child.
Yeah, I don't know if that's a good idiom to spread through the code, though. I don't know that you should be restricting yourself to a child when the property, in essence, is sort of a generic.
Yeah. So kind of getting halfway there, the information that's needed is there.
Yes, I did see the property there.
Yeah. So then it's
This question was more about the API.
Right. Yeah. Okay. I'm
not sure the answer to Mark's question. Was trying to think of another example where you'd want to expect that you wouldn't already have.
In most cases, you'll be producing the same type as your children. Yes, in a lot of cases where the 2 children are the same type.
That's certainly true for the math operators.
Most math opcodes is where, and then anything else is
stores and loads, like the indirect stores and loads, you already know.
Yeah.
Indirect calls, you know, to the extent that you can.
Yeah.
So maybe limiting it to compares isn't an unreasonable thing to do. They are kind of unique in that sense. Not unique, but rare. Different.
Yeah. Because ternary is a bit strange, but again, it produces what it gets in on both sides.
Yeah.
Okay, so I think that there's agreement that that's something that would be worthwhile. Do you want to propose an API in a PR?
Okay, sure. I can do that.
Okay. Good.
Yeah. If anyone has any strong feelings on names, please speak now just to save me one iteration on the PR.
Those suggestions usually come out when people see the name that you propose.
Yeah. I just thought I would preempt it if somebody already had a name that they particularly loved.
Yeah.
Good luck. Nobody steps up to that stuff.
Yeah.
I know. I thought I would ask the question at least.
Yeah. Okay.
In the forlorn hope that I didn't have to have 5 revisions on the PR.
Yes. Is there any?
When you have these compare double, those kinds of things.
How are those encoded? Because I didn't even
On the
find
opcode.
those.
They're also in the same file that you printed at OMR.
Yeah,
So
there's a giant switch case here.
It's just they're hacky.
That's not great.
Yeah.
Okay.
I hope there are no surprises in that particular list.
Well, I mean, there's an
That I didn't
opportunity.
look for.
Well, there's an opportunity for potentially cleaning that up, right?
Well, yes.
So
yes, that could
there's
go away.
exactly one use of is compare double in OMR.
The problem is there's a lot of these things which are done with switches that could really be opcode properties.
Well, this one here,
It's less CMP,
yeah.
kind of is greater CMP, is equal CMP.
That's a
It's not
query
equal
on the.
CMP. It's not it's a switch on the opcode.
Okay.
Can you
It's
branch out
direct
that?
load opcode.
It's function call. Yeah, there's a bunch that are just.
There's a lot of them.
Okay, so there's an opportunity here to potentially. This is outside the scope of Andrew's request for sure. So.
I was just trying to look to see if there was already a sort of a similar kind of API there that get a comparison without unordered.
Okay.
Get a corresponding logical comparison.
Corresponding logical. Okay.
Good long names in here anyway.
Okay. Is there any more discussion about this specific request? No? Okay. So we'll move on to the next topic, which is the usage of the TR namespace. And I'll let Leonardo take us through this one. Because you created the issue.
Right. Right.
Sounds like you have a can of worms. Here's your opener.
Well, it all started actually roughly a year and a half ago, when we had this same discussion, not in a compiler architecture meeting, but discussing what we wanted the TR namespace to be used for and try to figure out whether non-extensible classes should be put in the TR namespace versus the OMR namespace. And after much discussion, it appears the resolution was that everything should just go in the TR namespace, and documentation was written that says this, although it's worded in a bit of a strange way, but never mind that. And subsequently, there seems like follow-up discussions happened with the assumption that non-extensible classes go in the TR namespace. Then PR was open to modify a class, and one of the modifications that was done was to change it from an extensible class to a non-extensible class. And the question came up again about whether we actually want this to go in the OMR namespace instead of the TR namespace. Yes.
And there's one other, I don't know if you're going to get to it or not.
There was OMR versus OMR compiler?
Yes.
Right, yeah. So as a side discussion of that, there was other discussions with the OMR project as a whole about using namespaces for the different components of the project. And for the compiler component specifically, we would have the namespace inside OMR being OMR Compiler. And the implication of this for us would be then the decision of whether non-extensible classes go in TR versus OMR Compiler. From the first discussion that happened on this topic, to summarize a lot of what was said, things should go in the TR namespace if they are a complete entity. It was not well documented what is meant by a complete entity.
I think that's part of the confusion. Right?
Yes, probably. And then beyond that, there's also questions because we're trying to kind of move to this idea where APIs in OMR are inside a OMR component name namespace. This, of course, won't work for extensible classes because of their special static polymorphism mechanism. But for non-extensible classes, they really could live in the OMR compiler namespaces where it would make sense for them to live, but people have raised concerns about some of the implications this might have. So turning over the discussion to others that have previously participated.
From stunned silence.
Well, I think the easiest way of documenting this, like with the least ambiguity, I think.
Yep.
Not saying this is the correct thing, but with the least ambiguity would be basically saying that you use the TR namespace only for the concrete class of an extensible class, and everything else is an OMR compiler.
Yeah,
I think that'll work, but it's.
I agree.
And to be honest with you, I thought that level of simplicity. I mean, we could work with that level of simplicity. Yes. I wouldn't be opposed to that.
Simplicity is good.
I guess one concern I have about an OMR compiler namespace with a name that long is the verbosity that it's going to put in the code. I appreciate the need for the project to structure itself appropriately. However, having that long prefix on the start of many, many, many declarations is going to make the code very much harder to read because you're going to have to keep looking past all of this noise. And it will also increase, I feel, the tendency for people to use auto in places where it's not strictly required. And I worry that in the long term, people doing that may make it harder for us to do refactorings in the future where we've done experiments of the form, okay, change it, compile, see what broke, because trying to find everything is so difficult. And if auto allows the type to become malleable, you may not find the things that you're looking for because the inference ends up picking a different type that just sort of happens to fit. And the quack method is there, although it may make it bark. So I have a concern from that point of view because we like it worries me that it.
So does anyone know if any other components within OMR are considering to move all of their code? I guess GC would be the only one that's in C++. So the OMR GC component, has anyone expressed an interest in moving that into an OMR ::GC namespace?
Yes.
There was some, that one issue that was opened like a year and a half ago or so. The discussion in there kind of evolved to, yes, namespaces are good. And that's what we should be moving to now. We did take that to a formal vote at the OMR level, but and no PRs have appeared to move anything into that, to those namespaces.
Yeah, classic norm decision.
For reference, the issue is 1706.
I remembered it, but not the number.
September 21st, 2017.
I think that
so just to summarize other discussions that have happened addressing Andrew's concern, not saying this will be the absolute solution, but some of the things that were proposed is you can use a scoped using namespace statement, which would help with some of the declarations, not all. It wouldn't help with like a function declaration unless you were to just do namespace, OMR namespace, compiler, and then all of the function declarations, which is something we don't do in the compiler right now.
Yeah.
So that won't solve those. But if, say, inside a function, and you had a lot of variables that you needed to initialize, instead of saying OMR : compiler : type name, variable name, you could do using namespace OMR compiler at the top of the function, and then you would have access to everything within that namespace. So that would shorten some of those, but then it would shorten some of those variable declarations, but then you have to make sure you have using namespace at the top of every function.
Yeah, it would also make grepping the code base harder because the usings would make it harder to find the uses. The other thing that I'm aware of, having worked on a C++ compiler in a past life, is that not all C++ compilers have the same semantics with scope using declarations. Some of them treat them as forward declarations, some don't. Some of them treat them as points where templates are instantiated, others don't, which leads to varying behavior, which is something we always try to avoid with our C++ classes notion, since we tend to pick a set of compilers that tend to disagree on the semantics of the language rather frequently.
Another option that was proposed at one point that was discarded because reasons that will become obvious is C++ 11 allows namespace aliases. However, that's not supported in all our compilers, so but that's more of the discussion of OMR versus OMR compiler, which, given that the rest of the project doesn't seem to have.
Well, so under this model, where do the fully derived classes go?
They would still go in TR.
Well, can we separate the two discussions? Like, there's what's the semantics of TR and
I'm trying to get back to TR,
and then we can figure out
what the other namespace is later.
Right.
Yes. I would.
So other than the are there any opinions on the? No, what am I trying to say? like other than the length of the potential namespace, are there other concerns about what, or other thoughts on what should go into the, I'll just call it the OMR namespace versus the TR namespace? Like I said, the simplest proposal is to put only extensible classes there. But the other side of things is to potentially say, yes, you put concrete classes there, but anything that could be consumed by any other OMR consumer should also live in the TR namespace. But when you add that kind of ambiguity, and you don't necessarily predict up front that this piece of code is going to be useful.
I mean, so that
just motivates everything that's not extensible has to go into TR.
Yeah.
Which I think is a simpler consumption model.
Yeah.
In my head, right? Because anyone who's trying to consume the compiler now doesn't have to figure out if they need to look for a class in TR or in OMR. And the other concern which I raised in the PR is if an OMR class is used to construct a TR class, then if a class moves from being non-extensible and therefore its concrete implementation is in OMR to becoming an extensible class, then any consuming project that's already using that class is going to be reaching into the middle of an extensible class and not have any signal that that's necessarily a bad thing.
So TR may become an alias namespace for OMR compiler then. Like we are essentially saying that the OMR compiler classes that live in the TR namespace, which is getting to the way that it used to be when it was closed source, we had the TR underscore, which is what that was. So in effect, we're getting. But I still think you need to have an OMR namespace for the components of the extensible class, because they need to be.
So I was going to ask that question differently. So in the world where OMR compiler is where classes live, where do the OMR layer components of an extensible class go? Right now they're in OMR, which is
so then they would move
OMR
to OMR compiler.
Yeah.
Something.
Well, no, you just move everything. OMR. You replace everywhere where we currently use OMR.
Yeah, different question. I'm asking a different question. So right now somebody trying to consume OMR, looking at this from across components, I know I'm broadening the question beyond what you wanted to consider, but sorry, I think I have to do that. So if I'm consuming GC, I'm component thing. I'm using stuff that's in an OMR : GC namespace. If I'm using stuff in the RAS component, I'm using OMR : RAS stuff. So the natural, forgive me, place to go looking for compiler stuff would be in OMR : compiler, which means OMR : compiler is kind of what our TR is today in that model, right? Right? There is no more TR. We just renamed it OMR : compiler because that's where people should go to get compiler classes, right? And I'm not proposing we do this necessarily. I'm just saying in this model, that would be the consistent way of consuming OMR things. But that means OMR : compiler is TR. So what's OMR?
Yeah. No.
What's today's OMR in that model? Is there a colon? Like
right. Yeah,
real OMR. Yeah. Old OMR. OMR 2.
So when I was considering this, what I was imagining is we would not actually be replacing the TR namespace because the TR namespace is not just used by the OMR project, it's also used by downstream projects.
Yep.
And then we would be forcing them to add things to our OMR compiler namespace, overwriting, right? Because when they have to provide their own concrete implementations of a class,
they become part of the OMR
compiler namespace, which to me just seems more wrong than putting things in the TR namespace and then having the implementation of components be an OMR compiler instead. So that was the mental model I had.
Yep. I understand your concern. I don't think there's a good way around that, really,
unless we get rid of the static polymorphism,
Right.
we're always going to have that.
Yeah, I guess. Until extensible classes disappear, we're always going to have that problem.
Well, until the static polymorphic aspect of extensible classes disappears.
the downside of us not using CRTV, which there's no way I'm reopening that can of worms.
Next week's compiler architecture meeting.
No, architecture meeting. We're supposed to discuss all architectural things, right? Yeah.
For anyone on the call, people are currently thinking. Lots of thinking faces.
All right, so I guess the both pragmatic and addresses that issue is continue to use the TR namespace for at least classes that are extensible.
Yeah. Well, I would say yes.
Separates it from OMR. I mean, that helps with the the conception of I'm going to introduce my code. I don't want it to become part of OMR. It becomes this TR thing, which is at least not directly connected with the OMR implementation. It does help with that part. And then the pragmatic part is everything's TR right now anyway, so there's nothing to do to make that happen. So then we still have that open question of are classes that are not extensible, should they be in OMR or TR? Which I guess is the question we started off with, so it's good that we circled back to it. I don't know. I tend to look at that from a consumability perspective and think that they should be in TR, but
yeah, I would personally agree.
It simplifies, like, you don't have to think about where it is, and you don't get burned if it moves later, right? Like, if it moves later, it used to be TR, and now it's a concrete thing that's in TR that has the OMR thing in it, right? Like, you're still using a thing in TR, which should be the composed thing, at least from an OMR standpoint. And if you weren't, if it wasn't an extensible class before, then you have nothing to specialize in it. You're just using it as is, so you get what you get.
It also simplifies the namespace length. Presumably, you're okay with it. 2 characters.
Everything changes to TR instead of OMR. Like shortens everything.
Instead of OMR compiler.
Shortens a lot of things. Yeah.
TR. And we already have TR underscore in front of.
Lots of things that eventually should get cleaned up.
It's adding an extra character, though. TR underscore. TR code 1.
I am certainly willing to give one character. It's more
one character back in a lot of places too.
Yeah, it's just more like some long prefix or having to use usings or complex nestings is where I start to worry more.
We already have, as Daryl pointed out in that issue from a long time ago, we already do have 3 levels at least of namespaces that we're using for extensibility. So.
Okay, so do you think you could simply articulate the rules around, like this is it?
Everything goes in TR.
Yeah, I'm still a little, like, I agree with this in principle. I just still don't kind of like the compiler is off by itself out there with this TR namespace. Admittedly, we are doing something different than the rest of the project with the extensible classes. if we were to return to a non-static polymorphism approach to doing our extensibility, does that simplify them? Like, do we then have to revisit this, I guess, is the question, because then
we
the TR name
would, yeah.
doesn't mean anything anymore, right? Because you're just subclassing.
At that point, would our build compilers all support namespace aliasing? In which case we could alias.
I'm not sure that's a solution I want to bank on, right? Solve our complexity problem by giving it a name X.
I think the extensibility is going to be here for a little while longer.
Yeah, no, I know. I guess I'm just trying to get a feel for, are we pushing ourselves over here only so that we'll have to.
But one thing that, regardless of which way we go, I think we really need to strive to make the code base consistent, because right now we're in a very not even half and half. It's like a little bit. There's different flavors of the way that we're using it.
Thirds.
Yeah.
Actually, no, it's not. It's more like quarters.
Like there's the global namespace. We're using TR underscore global namespace. We've got OMR.
Some things use OMR. Some things use TR.
Yeah.
And then there's extensible classes. Use everything.
Yeah.
All at once.
All at once.
So
Grand
it
style.
would be nice to strive to at least get those, because then if we have to change it in the future, we're just changing it from one thing to another as opposed to herding all the cats in that direction now.
That does feel like something that would allow us to really call this description an architecture description or meeting rather than an architected solution. All right. Well, I'm worried as usual that Charlie hasn't had an opportunity to chime in on his complaint about TR. But
I think that the next thing, perhaps you could articulate what it was that we've as a proposal, right? And then we can get everyone those that are not on the call to comment.
Right. So what are we proposing?
It shouldn't be that. We propose that we
move things to TR.
Everything when you consume from OMR, OMR Compiler, you get it from a TR namespace. Of course.
Right. Okay.
Yes.
All right. So propose to maintain the status quo.
Aren't we fairly close to having a virtualized non-extensible solution, at least from the several PRs that are being worked on right now? And if accepted, I feel like this would change the outcome of the answer.
They're proposed. I think we need to do some performance investigation of them still. Would that
I don't know. Is it
completely get rid of the shape of the hierarchies, though?
You wouldn't get rid of the You would get rid of the
still
complete shape.
There are still some interesting questions that a virtual hierarchy raises. Right?
Yes.
Because then, at that point, the consuming project has to be the one directly enhancing both a base class and a subclass, like code generator, for example. If you want to add something to code generator in a project, it's a little bit hard to figure out how the hierarchy fits together if you also have an x86 code generator where you need to use your code generator's extension.
Right. So what I'm imagining is you would still have that partial extensibility with what we currently have called the connectors.
Okay.
But for the
But you don't use the final namespace.
Yeah, you wouldn't be using the final namespace.
You don't need the final namespace.
Yeah.
So basically, we provide mixins in C++.
Yeah.
Virtual. Right. So the hierarchy still gets stitched together the same way it's being stitched together now.
Yeah.
But how do you do that without a namespace? How does the x86 code generator know what class to extend?
Well, I would assume it would be extending OMR : compiler
Right.
code generator, and then
Right.
it would be in OMR compiler x86.
Right. So consuming project comes along, and I want to extend code generator, so I create J9 : code generator, for example.
Okay. Okay. Yeah.
And now my J9 x86 code generator, what is it? What is its
Right.
hierarchy?
So you would still have
because it doesn't have J9 code generator in it.
Right. You would still have to define like. Yeah. Right. It still needs something.
There's something missing there. Like I
but
don't
it could
understand
just be
how
a
that
type
works.
def.
Isn't this already implemented in the PR? I mean, there's an example. Can we just take a look how it works?
You're so pragmatic.
If there's questions, I mean, we can just ask. I forget his name who implemented it.
Summer.
Summer, yeah.
Actually, I think that in his proposal, he still has the TR namespace. So he still has the entire thing. He hasn't gotten rid of the TR part.
Yeah,
Did he do any?
he was doing the extensibility aspects are still.
Compilation of it. We have one for a simple hierarchy. That's what we put on.
I mean, one of the main motivations for that work that he was doing was to actually get rid of the self calls, because you're basically just using the virtual to handle all that for you. It's still got
That might be the only part that it
the
gets.
pointer to the pointer to the base of the hierarchy to the your base pointer is still the leaf of that.
Yeah. Right. Hold on. Lots of thoughts. Okay. So from what Mark was saying, he's right in that you would still need something at the end that kind of becomes the thing that somebody else is going to override.
Right.
The thing is, we could really just turn that into a type def, because the important thing is that at the OMR level, we no longer need to be referencing one that is provided by a downstream project.
So we used to, I don't know if this is so we used to use type defs there.
Yeah.
And the reason we stopped doing that, if I remember correctly, was because you can't forward declare a type def, which you might be able to now in later versions of C++, but I don't think you can in all our build compilers. You can't friend, at that time, you couldn't friend a type def, which we need in some of our classes. Right. And was there a third reason?
You need a third one?
I want one.
Okay, so to address that point about the forward declarations, right now we need to forward declare classes because we have to be able to forward declare the thing that's in TR, right? And the thing is, what's in TR can be either the thing we provide or one that's provided by a downstream project that gets resolved by the include path. With virtual polymorphism, that need goes away.
It's only the OMR base class that you actually use anywhere.
Yeah. So, which is why I'm thinking, I haven't actually done the experiment, but I'm thinking that using a type def will be easier.
Which is a concrete class, always.
Yeah.
Except that for the friend one. So the type def one I buy, but the friend one I'm not sure I buy.
Yeah, the friend one
So the friend, the predominant uses of friends, I believe, are in the debug class, which needs some serious overhauling, but more on that later. And then the other class that uses it, I believe, is Node. In the Node hierarchy, it likes to peek into things, if I'm not mistaken.
Definitely.
There's one of the just builder classes, like a method builder or somebody that has a friend. Too.
Yeah. So, so the way I'm imagining this right now is again, instead of making the concrete class the friend, you would just be making whatever class is at your level the friend. And you wouldn't be able to use the...
So if I'm in a J9, an open J9 debug class, I should only be friending
But you're never going to have a direct reference to one of those. You're always going to have to, I guess in that case it's a virtual hierarchy, so you can't cast to your type. But
Yeah.
really, you don't have to be bothered by that. Okay.
So another thing to be thinking here is whether or not any of these restrictions is going to make this kind of a hierarchy easier to use or harder to use. Because
I was liking the fact that the cast all melted out. But all right. If that's the price, then that's the price. I mean, I can see some advantages to this. And if we get rid of the need for a TR namespace, that certainly simplifies the issue that we, in fact, everything kind of gets simplified if we move away from that model. All right? That's why I asked the question, I guess. Or you asked the question too.
so
has he looked at the instruction hierarchy yet? Because I remember that one being a particularly
he was focusing on
one to figure out.
So in terms of my understanding from the research that he was doing was he was focusing on the more popular classes to do some performance measurements with. So I think he focused on CodeGen.
I see CodeGen, I see compilation, and I see symbol.
Symbol, yeah.
Maybe it's got CodeGen somewhere else. Oh, memory reference too.
I think
that's a good one.
Yeah.
But instruction was the one that I remember there being a lot of struggle with.
Instruction and CodeGen are the ones that have the most but they also they're the ones that actually use the architecture specializations and even sub-architecture specializations in some cases. So
just
so is coming up with an answer on what we're going to be doing. What's the future of extensible classes? Is that a prerequisite for answering this question about the namespace? Because
so is it what's the priority behind the question being asked this time?
I think the priority is
what
more.
question are we asking?
Well, the priority is that it actually.
Why are we here, Leonardo?
Yeah.
You opened the issue.
It's really to provide some clarity around the text that we currently have, the guidance that we give on when to use the tier namespace, because it did someone who is not familiar with the project, like many of us are, did come across an issue where he needed to decide where to put the class that he was working on. In this case, it was register iterator. And based on the guidance that we have documented, it's in the TR namespace, but clearly there's some differences of opinion on where things should go. So it was really to clarify that. So what the future of extensible classes, I mean, there's an entire research project that started to figure that out. So it may not be something that's coming, we're going to have an answer for in the next few months, right? It could be a multi-year endeavor. So.
Well, I mean, the whole consumability model changes when we eliminate that namespace, right? Like if we go to a virtualized hierarchy, then there is no more single place you go to get things. Are there any things that people would, are there any non-extensible, the question I'm trying to ask. Are there currently any non-extensible classes that are in architectural namespaces? Like, does anybody directly use an OMR : Z : thingamabob if someone was consuming OMR? Or are they getting it from an OMR that has some Z, that has like Z in the name or 390 or whatever in the name?
I think the answer should be no. However, I do believe
that was an either/or question. So
I think there's a the Z.
So I wasn't meaning to pick on Z. I just happened to look at Philip when I was thinking formulating the question.
So I said Z.
The J9Z memory reference class derives. So the J9Z namespace derives directly from the OMR Z namespace. So it skips over the usual connection mechanism. But the reason it does that,
I believe, it's an extensible class.
Even though it is, yes.
Okay.
And I believe the reason it does that is because J9Z wants to skip over the J9
Yeah, I got it.
because of the constructor. It wants to flow it's got special constructor parameters. It wants to flow them directly into the OMR. And J9 is a pinch point, which is common across all architectures. So there are, I don't know, we may even have an issue around cleaning up the whole constructor story for these extensible classes. But anyway, that's an example of where we cheat.
Cool. Right.
We hotwire it, you mean?
Uh-huh. Okay. Sorry, I really wasn't picking on Z there. Just happened to pick one with a good example.
I think there used to be...
So the answer is yes.
But that was an extensible example.
There may be other examples in the symbol hierarchy as well.
That's also an extensible. I'm asking about non-extensible. Right. So right now people are using classes that are OMR : blah.
I don't think there are any actually that are using those namespaces.
Okay. So there's going to be a bunch of stuff in the P cogen that will be in the OMR namespace, but not in the OMR : P namespace. We'll be using the OMR : whatever.
Power.
Yeah.
Yeah, I don't. You change the architecture, it doesn't change my answer.
Just trying to be equal opportunity.
Okay.
I mean, I guess the one other point is that, like, just looking at other major things, like LLVM has a pretty flat namespace structure, right? They just do LLVM : and the whole kitchen sink just ends up underneath that. The code generator is the optimizer, the debug tools, the dynamic typecasting, the C++ munging.
But LLVM, it gets. You don't actually extend that directly, do you? You build that into a library.
Well, it uses the CRTP.
There's lots of CRTP that involves it, and there are lots of people who consume it and then stick other stuff on, sometimes by directly putting it in and sometimes by being slightly more elegant than that, because upgrading becomes a nightmare if you just do the former. But they certainly don't distinguish. Probably to avoid discussions like this.
Well, I wonder how much name clashing we actually have between all of the C++ components in OMR right now. Like, if we're not clashing.
I think most of the class names are already smurfed in some way, like the GC ones are MM underscore something. A lot of ours are TR underscore. And then we throw a namespace on top of that.
Well, in that case, there probably isn't much value in adding, notwithstanding that I created OMR : JIT builder, but maybe there isn't much value in creating OMR : GC, OMR : RAS. There's C++ code on the RAS component. OMR : compiler. Just call it OMR.
Surely clashing names between those components suggests that we have a bigger consumability problem about trying to figure out which of those things you're actually trying to talk about.
You can see it in sort of more fundamental utility type stuff, but that's actually maybe we should be unifying some of those, or just smurfing to get.
Playing devil's advocate, we have name clashes in the compiler by itself with TR underscore resolved method and TR : resolved method.
Yeah.
So now that's a bad example, and we should not do that ever again. But it could happen.
Right, but
Can you fix that by January?
Actually, I was going to say that I'm going to rip that Band-Aid off sometime in the new year. So let's get ready for the...
Right, but like from the philosophical point, which is kind of what we're driving at, if we've got name clashes between the components in OMR, we need to fix that, not by using a namespace, because otherwise, how do you know? Or what is the difference between the widgetizer in the GC and in the JIT? Like, they are named the same, and if they're very similar capabilities, why are there two?
OMR GC list. OMR compiler list.
Hash table, isn't that?
Oh, right.
Our 5 hash table.
I'll be burning those, all right? I've almost got rid of the CS2 ones.
Bit vectors next.
CS2 bit vectors are almost dead anyway. We can I'm all for burning the CS2 bit vectors, but anyway, that's aside.
Okay. Have we made any progress here?
Back. I believe we are now befuddled.
I mean, looking at the future, I don't know if we can rely on the future of Extensible. We can't look into a crystal ball and predict that we're going to get rid of extensible classes at some point, because I think that is very much a long-term thing if it does happen. Like we're looking at years, I think, rather than months, unless someone is like super committed to doing it, and they're going to be.
All right. So then, to my mind, that still brings me back to the original thing, which is that we should put it all in one namespace so that people know to consume from one namespace, and then if extensibility changes in future, that namespace that they'll be subclassing will just become a different. Like, yes, they'll have to change their code in other ways too, but primarily they'll be moving extension point, like superclasses, from being in the TR namespace to being in the OMR namespace at that point.
Yeah, I think if
or OMR x86 or whatever, right? But it'll be.
I think if extensibility does ever change, then there's going to be impacts to downstream projects already.
Yeah, certainly, but trying to minimize that so it's not like you did it in all in one place, now you have to do it in all over kinds of different places, or you were doing it this way, and then we said, no, do it that way, and then we change extensibility, and it's like, okay, go back to the way you were doing it before. That's not a great story either. But I think
We're being agile, iterative.
yeah.
Infinite loop.
Who gets to be the hamster on the wheel? I don't know. To me, it feels like solidifying on the TR namespace is the easiest consumability model going forward, right? And even if we are going to migrate people away from the current solution to a different type of extensibility, having everything coming from one place makes it easier to describe what to do going forward, as opposed to if you have one of these, then do that, or if you have one of these, do that, or if you did one of these crazy 7 things, go figure it out and tell us how to do it.
And if you did the 8th thing, fun shots.
Yeah. But migrating from a state of consistency is presumably easier to describe.
Mm-hmm.
And it kind of makes people's code easier to read too. All the same namespace. Not sometimes TR, sometimes OMR, sometimes global.
Okay. Does that make sense?
Yes.
Okay, so I think it should be a fairly simple proposal.
Yes. Just put everything in TR.
Right. And
Right. So I guess that then the big thing that will have to happen is we will document this
change
rule.
change the documentation there.
Yes.
That would be the
and
way that we propose it, I guess, right?
Right. And make sure that it's not just buried inside the extensible class documentation, which is where it currently is.
Right. Because it's not
Yeah.
specific to extensible
Yes.
classes.
I think if you're going to write this down, you should write it in the context of that. I mean, I know it's a complicated discussion that we had here, but like if the grander story is
Right,
like
right,
even
right,
though
right.
the grander story, we're trying to move the bigger story towards
Yep.
a more consistent story with the rest of OMR and a simpler model, we need to get everybody to a consistent place first.
Yep.
Right? Because that thing's not going to be decided for a while because it's a research project and no one's pushing forward on it except the research people. And 2, or they're doing it at their pace, which is fine, but it may take a while still. And in the meantime, we want to get to a consistent place and then be able to have a simple migration story to whatever the new world order is.
Okay. Yes.
Okay.
Cool.
Any more discussion?
It's amazing. We got 6 people to agree on something. Oh, and there's people on the phone?
Yeah.
Cool. Good.
Okay. Any more discussion on that topic? No?
Safely let that one.
Okay. So that's the last topic for this week. So we'll adjourn the meeting now. Thanks, everyone, for attending.